guys, I'm Chiku from Chiku Study Corner. So it's the second part of electrochemistry that I'll be taking today. Without any further ado, let's get into the video. Before watching the second part, make sure you have seen the first part because it's a continuation. So we learned what is SHE in the beginning. What is SHE? Standard hydrogen potential. We learned about electrodes and electrolytes in half cells and electrochemical cells. But how will you put an electrode of a gas, for example hydrogen, nitrogen, how will you put that if you have to have as an anode or cathode? That is what I am going to show you today. So now what is standard hydrogen potential? How would you make a electrode out of hydrogen? Because hydrogen is a gas, electrode is a solid. How can you make an electrode? So this is the setup of a SHE. Let's see what all are it. This is actually a platinum wire, PT wire. This is a platinum foil covered with platinum black. I'll tell you why it is platinum used inside a hydrogen potential, to show hydrogen potential. I'll tell you. And this is a valve where hydrogen is flushed inside. Always continuous flow of hydrogen is given inside it. And then obviously what I told you, if now we've taken this to be hydrogen electrode, then this has to be the electrolyte of hydrogen. So we'll take this to be HCl. And then it's inside a glass chamber. The platinum wire is kept inside a glass chamber. Why is a platinum wire used? Because it's an inert electrode. It's an inert electrode. It doesn't participate in the reaction, but it gives surface for the reaction. So platinum doesn't participate, the hydrogen would participate only, that acts as a surface. Okay. So now we learn about the reactions and how and then a main thing to tell about hydrogen potential, SHE, is it is taken as a reference. It's reference because hydrogen, the E0 H plus slash H2 is equal to 0. It's a reference point. It's 0. Okay. So I'll tell you how SHE works as anode and how SHE works as cathode. So I'll show you. As I told you, SHE always works with only standard conditions. I told what are the standard conditions in my last session. Standard conditions are 1 bar pressure, 1 molar concentration and 298 Kelvin. So the hydrogen that is flushed inside that setup, the SHE setup, is always 1 bar, and the concentration of electrolyte or HCl inside the beaker is 1 molar. So we learn about how it reacts or how it works as anode and cathode and its reactions. Why does SHE work as both anode and cathode? How does it work? On what basis? It works on the basis of the electrolyte, the electrode in which it is coupled. So we learn the reactions. Okay. First one we learn anode reaction, then we'll move on to cathode reaction. So anode, where oxidation happens. So we learned oxidation is something which transforms or turns into a positive number where ions comes to the left side. Let's see. H2 giving 2H plus 2 electrons. That is the anode reaction. And the cathode reaction is the right opposite. 2H plus 2 electrons giving H2. So I told you this depends on the electrode used or the electrode with which the SHE is coupled. So if copper is coupled with SHE, then SHE would become the anode and copper would become the cathode. Whereas if it is kept with zinc, it will become the SHE would become the cathode and zinc would become the anode. I will show you the representations and how do you calculate the electrode potential of various electrodes. So now I'll show you the representation, half cell representations of both SHE acting as anode and cathode. So let's see for anode first. Anode, when you represent it, it is anode slash anode ion. So what is the anode over here? Anode is H2. when you write H2, I told you H2 is flushed in. There is something else in the container. What was that? There is platinum. So make sure you mention platinum also. It can be either towards your left or it can be in the right side also. Any side you can write. Okay. Either PT's comma H2 slash H plus. This is the anode representation. When it comes to cathode representation, it will become, that is cathode ion slash cathode. Okay. Cathode ion over here is H plus. H plus slash H2. H2 also has PT, no? Whether it is anode or cathode, platinum is the surface. So we have to mention PT. So this is the cell representation. Now we'll deal with what is the or how do you calculate electrode potentials using SHE as a reference. Let's see. So now we are learning about measurement of electrode potential. So how do you measure an electrode potential? First thing is that every time that you have to measure an electrode potential, the voltmeter reading would be given. So what you have to do is just connect the given. If you have to find about example for magnesium or something, you give that as the either anode or cathode, which is coupled with hydrogen electrode, that is SHE. First we learn about zinc and then copper. We always learned about Danielson, that is why I am taking the example of zinc and copper. The first one is zinc, so we learn about it. So first here our electrode is zinc, our electrolyte is ZnSO4. This is hydrogen, this is SHE. Here in the case of zinc, what happens is zinc is anode and SHE is cathode. Now we will see how you calculate it. We know E0 cell is equal to E cathode, E0 cathode minus E0 anode. I told you in the last session about this. So E0 cell, what is E0 cell? The cell potential. I told you cell potential is what it is given by the voltmeter. So our cell potential in the case of zinc electrode is 0.76 volts. So it's minus 0.76 volt. And then what is our cathode? Cathode is SHE. So I told you SHE is 0. Electrode potential of standard hydrogen potential is 0. Therefore, it is 0 minus E0 anode. That is what we have to find out. So, E0 anode. E0 anode. So, now we have got that 0.76 volt is equal to minus E0 anode. Therefore, E0 anode is equal to 0.76 volt. Sorry, minus 0.76 volt. That is what is the how you find the cell potential. Sorry, electrode potential. Next, we learn about copper. That's why I've drawn 3 tumblers, not because it's having a 3 tumbler setup. Now we'll remove the copper wire in the zinc, and now we'll put it to copper. Yeah. Our salt bridge is also removed. Now we have a salt bridge here. Yeah. This is a salt bridge here. Here always hydrogen is flushed in. There's no need to mention because that's standard hydrogen potential. And then this talking about copper, what would be its electrode? Copper. Its electrolyte CuSO4, and this is always SHE. I'll show you how you calculate it. Yeah. So now we're dealing with what is how do you calculate the electrode potential or measurement of electrode potential of copper. We know that over here I've mentioned it is not 3.4, it's 0.34 volt. Okay, it's given 0.34 volt, it was my mistake. Now we know what E0 cell is equal to E0 cathode minus E0 anode. What is our cathode and anode over here? Our anode over here is SHE and our cathode is copper. We'll write. So 0.34 is equal to cathode is copper. So E0 cathode minus 0 implies E0 cathode is equal to 0.34 volt. Hence we have found out what is the electrode potential of copper. So that is how you measure the electrode potential of various electrodes. It can be anything. Anyway in the question, the voltmeter reading would be given. Just you have to find out whether it will act as an anode or a cathode. Then proceed with the reaction. Electrochemical series. Electrochemical series is way similar, or it's very similar to our reactivity series. In reactivity series, the metals are arranged in their reactivity according the order of their reactivity. So let's see what is electrochemical series. So the definition of electrochemical series goes like this. Various electrodes are arranged in the order of their electrode potentials. So it can be the increasing or decreasing order. We will define it as to be the decreasing order of arrangement. So let's see, there are some applications, 5 applications. We learn each application. The first application is to compare the relative oxidizing and reducing abilities. So if the E0 value, that is the E0 values are what which is given inside the electrochemical series. So if the E0 value is high, if it is very high, then it shows a tendency to undergo reduction. A high tendency to undergo reduction implies what? It is a good oxidizing agent. And if the E0 electrode value is low, then the tendency is to undergo oxidation. High tendency to undergo oxidation, and therefore it's a good reducing agent. That is our very first application. A second application is to calculate the E0 cell. So the second application is to calculate the E0 cell. So we know E0 cell is equal to E0 cathode minus E0 anode. So if you have to get cathode and anode values, just look at the electrochemical series. So how do you understand which is cathode and which is anode? If the electrode potential is higher, if it has a higher value, then it is cathode, and the lower value one is the anode. So we'll discuss a third application. So the third application is to predict the feasibility of a reaction. So if the reaction or the cell potential for reaction is given as positive value, then the reaction is feasible. That is, if E0 cathode minus E0 anode is equal to a positive value, then the reaction is feasible. Whereas if E0 cathode minus E0 anode is negative, then it is a non-feasible reaction. So that is the third application. Now we learn the fourth application. The fourth application is to predict whether a metal can liberate hydrogen from an acid or not. So here the electrode potential value is what that is matter. So electrode potential value, that is E0 Mn plus slash M. That is, this is Mn plus slash M is just a general representation of metal. Metal starts with M, so that is why I represent it as Mn plus slash M. If it is positive, then it will produce it will liberate hydrogen from acids. Whereas if it is negative, it will not produce hydrogen, or it will not liberate hydrogen from an acid. So let's discuss the fifth application. That's the last application amongst all, so we'll discuss that. So the fifth application is to predict whether a metal can displace another metal from its salt solution. So yes, the answer is yes. A metal with a lower E0 value can displace another metal with a higher E0 value. So I told you E0 value can be found out through the electrochemical series. And that is all about the applications of electrochemical series. So we've come to the end of this part, and I've been uploading notes below in my description. Please go download it and read it. I've done that for the same in the last part also. So if you like my videos, please do like it, share it and comment. Also subscribe to my channel. So see you in the next part. Bye bye.